You're just in time for the, yes, you want that. Yes. Yes, let x equal eat the orange. So we are going to take a look at how to optimize a variety of values using our knowledge of quadratics. Here, the student council, I'm just going to go through and highlight the most important numbers. They sell 500 sweatshirts when they sell them at $45 each. They're planning to decrease the price to generate more sales. So their sales are going to go up as they lower the cost. A survey was taken and shows that every time they decrease the price by $1, so that's minus one decrease, okay, they can sell more, 20 more sweatshirts. So let's let x equal, the trick that I showed you during the lecture was let x equal the number of times you change the price. It's not the only way to set these types of problems up, but it's the easiest way. Let that be the number of times you change the price. Let x equal the number of price changes. Notice that x will change both the number that they sell and the amount they make per sale. So write an sorry?
Isn't there only two?
To what?
Sorry, one price change?
Well, they can for every dollar they decrease it. So they could decrease it $5. That'd be 5 price changes.
Wait, so every time they decrease $1, it adds what?
20 sales.
And how much is each sweater?
45 to start, but that price is going to change as they start decreasing it to drive up their sales.
And so it's at like what point is the most they can decrease it and the most like profit they can make without having it too cheap, so it's like you're making $1 a t-shirt.
Well, there is a price where they're making $0 a t-shirt, right?
Yeah.
Yeah, and that's a useful thing to note, is that there are prices where you'll make $0 per sweatshirt sold, or there's prices where it's so expensive no one buys it. So those are your two zero profit points. Your vertex is going to be exactly between those 2 points. But we're completing the square today, so we don't care.
See, I'm definitely the type of person that like buys that.
Does it have how much it costs to make?
It does. It does, and that's what I'm gonna. That's my brain twister at the end, Alex.
Because without that, you can't like really do that. Because then you can have them as cheap as you want. You can have them $1, and like every single second, like 40 of them are being sold. So it's you making as much money as you want.
If you had a cost of $20 per shirt, that would still give you a profit margin of 25 if you're selling it at $45, right? And that's pretty good business. You know, if you can buy for 20 and sell for 45, that's awesome. But it is going to mean that if you lower the price to $20, that's your zero profit point. So it's going to shift that whole parabola around. It's going to lower your maximum profit. All of this should be like, yeah, that intuitively makes sense. My overall profit is going to be a lot lower. Here in this situation, somehow they have an infinite supply of sweaters. They just like sell them for whatever price they want. They get them for $0 or something. So it's a little weird, but we can still do the math. And then I'll show you where the math changes if they have a cost per sweater of we'll say $20. So we know that the number of price changes, we're going to let x equal that. Now the selling price of the sweatshirts, we're going to say the P is price, and that's going to be equal to, what's the price of the sweatshirts? If x is the number of times we've taken $1 from the price. Sorry? 45 minus x is going to do it. 45 is the initial value. That's the price if we did not change the price. That's the price with 0 price changes. But then we're going to subtract the value x from this is going to give us the new selling price. If we change the price 5 times, the price is now $40. Okay? So that's the selling price of the sweatshirts. If we have an expression for the number of sweatshirts sold, well, we have the number, so I'm going to call this n, and that's equal to an initial value. When x is 0, before they change the price, it's 500. So that's going to be 500 is our initial value, and then we're going to be adding some amount of sales every time we decrease the price. So every time they decrease the price, we sell an additional 20 shirts. So what's my equation here?
500 plus 20. 500 x.
500 plus 20x.
500 plus 20x. Now let's take a look at why this is the correct answer. First of all, if it was 500 plus 20, we would just say that's 520. And then it wouldn't matter how much they changed the price, their sales would be constant at 520. And that doesn't feel right. If it was 500x plus 20, then every time they increase the price, they would sell 500 more shirts. And that's like, oh, we don't quite have that. So the way I test and see if that's correct is I test different values of x and I say, do I have it? And then, yeah, I've got it. But then when I can see it this way, I can look at this. This is my y equals mx plus b. This is my initial value, 500. And this is my slope, my change per change in x. Here's the change per change in x. So that should click with our work on lines. Now to create a quadratic, we can multiply a line by a line, and that will make a quadratic. So write an equation for the revenue. Revenue is equal to the number they sell times the price. Do you agree?
Yeah.
The number of shirts they sell multiplied by the price per shirt, that's their revenue. And then what we can do is write that out. So then revenue would also be equal to the number they sell. That's this, 500 plus 20x multiplied by 45 minus x. There. That's the equation that models their revenue. You want to take a look at it in Desmos? Let's take a look at it in Desmos. Y'all have Desmos on your calculators. So this is on your phones, I mean. 500 minus a plus 20x, put this in brackets, multiplied by 45 minus x.
I thought they were supposed to draw a diagram.
Draw a diagram.
Yeah.
Yeah, well, I like to look at things in Desmos because I'm lazy. No, I'm not. I like to understand things thoroughly. I want to see values of x that go to, say, we'll say negative 35. Wait, negative 35. And we'll also look at values of x up to 50. Okay? And then we want to see values of y up to about 25,000. There we go. Okay, so now I changed the scale so that I can see this. If you don't like using Desmos, maybe this is your problem. You don't know how to change the scale. You need to be able to see the thing you just graphed, right? So there, if you're really not sure, you can just click like plus 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 until you see it, or you can just guesstimate what these values might be. There, look, there's the maximum profit. Right there. It's that when they've decreased the price 10 times, their profit is $24,500. By graphing, we've solved it. We're done. So that's solving this by graphing. Okay, so that's one way to do it. But if it's on a test and it says find it by completing the square, then we have a few more steps to do, but we'll find the same info. Here's the initial value. This is their profit if they're selling them with 0 price decreases. Okay. Now, actually, this would be a good spot to look at what happens to their profit if they have costs. So, hey, Alex, you're going to want to pay attention for this part. Instead of this being the sale price of their sweaters, let's make this their profit that they make per sweater. So if they had costs, like let's say they have to pay $20 per sweater, there, look at that. They were already optimizing their profit. If they decreased the price by, if they had to pay $20 per sweater, and their profit would have been $12,500 in that case. When I just subtracted 20 from here. If I make their costs even more, actually they need to increase their costs here to maximize their profit. That's costing them $30 per sweater. If the sweaters cost them $10 each, they can still afford to increase the cost 5 times. So I can get so much information so quickly by playing in Desmos. Y'all want to play in Desmos more often than y'all do.
When was Desmos created?
When was it created? Sometime after I graduated university in math and all that. This is like, I did all of this playing since I became a teacher. I love it. It's so great. I've learned so much just by playing in Desmos. So anyway, let's go back here.
I thought we were not like using Desmos.
Yeah, pretty much that's the problem. But you can use it as a learning tool. Use it as a learning tool. You want to get as much information in as possible. So let's see, the maximum revenue from sweatshirt sales. So we want to find that. What I can do is take this, R equals 500 plus 20x times 45 minus x. And if I want to find the maximum to this, there's so many methods. And people want to see completing the square today, so I'll show you completing the square. I first need to turn this into standard form. So standard form would be negative x times negative plus 20x. That will give me negative 20x squared. Negative x times 500, that'll be minus 500x. And 45 times 20x, that will be plus 900x. And then 45 times 500, that will be 45 times 500 is what? What is that? Someone needs to tell me that. I don't want to do that in my head right now. Who's my hero? Who's going to calculate 45 times 500?
Oh, I think it's 40,000. Oh, wait, no, it's 5,000.
Sorry? 225?
Yes.
225. Like that? 22,500? Cool. Okay. So now we're just going to collect our like terms. Negative 20x squared plus 400x plus 22,500. Okay. Now factor out my 20, my negative 20. So you're going to factor out your negative 20 here. Boo. You're going to have x squared minus 20x plus 22500. You're going to add and subtract 100 to this. Because you're going to take negative 20, you're going to divide it by 2 is 10. Then you're going to square that. Well, negative 10. And then you're going to square negative 10, it's 100. So you have, this is equal to negative 20 times x squared minus 20x plus 10 minus 10. Sorry, plus 100 minus 100 plus 22500 equals negative 20 times x minus 10 squared. That's this. X minus 10 squared. And there's your answer. Positive 10 is your answer. Increase the price 10 times. That's your vertex. And then you take this negative 100, multiply it by negative 20, and so that's plus 2,000. Negative 20 times negative 100, positive 2,000. So you're increasing your profit by $2,000 by changing the price 10 times. And then we're going to add that to this. So that's going to be plus 24,500. That's this plus 2,000. Follow me there?
Now, I have a question.
Okay, Johnny?
Where'd the minus 20 come from in the
In here?
like brackets?
Yeah.
Oh, I factored the minus 20 out of this.
But why? Like, it just makes no sense.
It's negative 20 times negative 20, 400.
Positive 400, yeah.
Oh.
See, we factor negative 20 out of 400. It gives us negative 20. 400, Johnny, is 20 squared. But it's also negative 20 squared. So if I divide 400 by negative 20, I'm left with negative 20. So there. So this has a vertex at 10, 2, 4, 5, 0, 0. Okay, that's the location of the vertex. That tells me if you want to maximize your profit, Students' Council, lower the price by 10 times, means minus $10, means you were selling it at 45, now sell it at 35. You'll maximize your profit because 20 more people buy it for every price, so 200 more people will buy it. That's going to drive your profit up. After that, more people will keep buying it, sure, but you're driving your price down so low that your profit starts to fall again. And this is your maximum profit. So notice when we look at this graph here that we see here 22,500. That was the C value in our standard form. When we completed the square, we had to add 2,000 to that to get up to the vertex. That's our maximum profit there. So that's kind of neat that thing that pops out when you add and subtract that number to create your perfect square, that thing that pops out is the difference between the C value and your optimum value. There. So this looks like this. Pew, pew, wee. And there it is. 10, 2, 4, 5. Oh.
Where does 24
Yeah, shouldn't it be 20?
Oh, this one here? 22,500.
Well, no, I know that. But
I have it at the very end.
Yeah, the very end.
Well, you see this number here?
Yeah, 100.
So this negative 100 wanted to come outside the bracket to play. But before it could go outside, its mother said, here, put on your coat. We have to multiply by that number before it goes outside to play. So negative 20 times negative 100 is positive 2,000. And we see that positive 2,000 over here, right? You see that $2,000 increase in profit. That's a lot of money for Students' Council, that extra $2,000. They're going to take that money and go build a garden. And it's going to be a beautiful garden, and people can go eat their lunch there. And there's going to be cigarette butts all over the place, and everyone's going to be angry. What a waste of $2,000. What price would maximize revenue from sweatshirt sales? Well, no. 45 minus X equals, well, 45 minus 10 equals 35. $35 will maximize your profit.
I went the wrong way.
How many sweatshirts must be sold to reach this maximum? So we will just look at the number sold is 50 plus 200 times X and see that 500 plus 20X. X equals 10. So this is 500 plus 20 times 10 equals 700. Therefore, they will sell 700 sweatshirts. They'll sell them for $35 each. That will maximize their profit. We already saw that if they were having to pay $20 and their profit margin was only 25, that's too deep a cut. They can't cut that far into their profit. They were actually already optimized if they were getting a $25 profit per shirt. Okay, let's take a look at the next one. Oh,
Can I just take a picture of it?
yeah, let me just pause the video.